These are arithmetic sequences. And arithmetic sequences can be used to look at examples like this. The starting salary of an employee is $21,250. If a raise of $12.50 is given each year, in how many years will the employee's salary be $50,000? So if you'd like to take a moment and pause the video and give this a try, feel free to do so. Otherwise, let's look at some vocabulary that relates to arithmetic sequences. A sequence is very simply an ordered list of numbers that are called terms that follow a pattern so that the next term can be determined. So a sequence is a list of numbers in a particular order. This one is 5, 10, 15, 20, 25, 30. You might be able to see the pattern, and we want to recognize that they're in a particular order, and our first term is the number 5, then we have the second term, and the third term, etc. And we can even call this T for term. The first term in a sequence is a special one, and we label it as T1. The number of terms in the sequence is n. Any term of the sequence can be called Tn. We read it T sub n or Tn, which is dependent on the value of n. For example, the third term is T3 and the eighth term is T8, and so on. T1 is our first term, T2 is our second term, T3 is the third term in the list. A couple more definitions to look at. We can have a finite sequence, which has a finite number of terms, whereas an infinite sequence keeps going and going and going and has an infinite number of terms. We can also have different types of sequences, and today we're looking at arithmetic sequences, which is an ordered list of terms in which the difference between the consecutive terms is constant. And we can also say that it has a common difference of d, and we'll look at that in more detail in a moment. Let's look back at the example we started with. For this problem, what is T1 and what is d? Well, T1 is our very first term, so we can use the clue that we have a starting salary, so this is happening at the beginning, of $21,250, and then d is that common difference that it's changing by each time. So the fact that we're getting a raise every year of $1,250 could be our d value. So T1, the first term, will be $21,250, and d, the common difference, or the amount that it's changing by each time, will be the $1,250. So how can you find T2 using the information of T1 and d? Let's imagine in this situation we're actually starting with $21,250, and in the second year we've gotten our raise, so we're going to add the $1,250. Now let's try T3. If we think back to starting with T1, we've got our $21,250, and we're going to have to add our raise in year 2 and add our raise again for year 3. So what we're really doing is we're adding the $1,250, but we're doing that 2 times. So I'm going to write times 2. And one more time, with T4, or our fourth year, we know we started with $21,250. And we know that we're getting this raise of $1,250, but we've gotten the raise 3 years in a row, so I'm going to times that by 3. And if we look back to, in general, what has happened with T2 and T3 and T4, what we've got each time is that we started with T1, and we went ahead and we added the common difference a bunch of times. The first year we only added it once. The second year we added it 2 times. And in our third year we added it 3 times. And now we want to look at whether we can come up with a pattern, convenient in math, that can help us find any term at any time. So let's have a look at our T2, T3, T4, and notice that it's built of T1s and Ds, and all that changes is each time the number of Ds. So we can develop a formula for the general term of an arithmetic sequence, and it will look a little something like this. Any term will be built of your T1, your first term, plus you're going to add on to that the common difference. Leave yourself a little space. Common difference, and you're going to add the common difference a bunch of times. And the question is how many times? So I've got my n, and I know it has something to do with the term I'm on. I'm going to go back a slide. If we look at term 2, we had T1 plus D. Really, we know there's an invisible little 1D. So how does 1 relate to the 2? Let's look at term 3. How many times did I add D? Well, I added it twice. And one more. For term 4, I added D 3 times. And we can see that each time, the number of times we add D is 1 less than the term we're on. So how do we show 1 less than n? Well, 1 less means minus 1. So we are doing n minus 1. And now we have the general term of an arithmetic sequence, which can help you find any term or any piece of the formula. Let's use this in our example to calculate something new. So we have our example, and we're going to answer the question, which was, in how many years will the employee's salary be $50,000? So we have to try to figure out what this $50,000 actually represents. And for us, we know what the T1 is. We decided that T1 was equal to 21,250. We know that the D, the common difference, is 1,250. And we know that at the very end of all of these changes, we land at $50,000. What we don't know is how many years it took to get there. How many times did we add on our salary increase? So what we're actually looking for in this problem is, what does n equal? Which means hopefully we know Tn. And Tn is the last term in our list. So using all of this information, we are going to write out our formula, fill in everything we know, and solve for what we don't know. So the formula is Tn equals T1 plus n minus 1d. Tn is $50,000. T1 was 21,250 plus n, which we don't know, minus 1 times d, 1,250. And now, like in any math equation, we filled in what we know, we can solve for what's missing. So our job is to isolate n, and we're going to start by doing the opposite. We start with our add or subtract step first. I'm going to subtract the 21,250 from both sides, which will leave me with 28,750, which equals n minus 1 times 1,250. And at this point, some of you might be tempted to multiply in to your brackets, but I'm going to say, let's not do that. We're trying to get n alone, so let's get rid of the 1250 instead. So I'm going to go back in time, divide by 1250, same thing to both sides, which will leave us with n minus 1 on the right-hand side, and 23 on the left. So we're really close, but our goal was to get n by itself. And right now n is being subtracted by 1, so we're going to add 1 to each side, which leaves us with n equals 24. Now let's go back up to our question and remind ourselves what we were trying to find. We were looking for, in how many years will the employee's salary be this? And we've decided that n equals 24, and that makes sense that it would take 24 years to reach the salary of $50,000. All right, let's try this from scratch with another example. Many factors affect the growth of a child. Medical officials encourage parents to keep track of their child's growth. The general guideline for the growth in the height of a child between the ages of 3 and 10 is an average increase of 5 centimeters per year. Suppose a child was 70 centimeters tall at age 3. Write a formula that you can use to estimate what the child's height will be at any age between 3 and 10. So anytime I'm asked to write a formula, I'm going to start with the general formula, which is Tn equals T1 plus n minus 1 d. And then I know that it's my job to find T1 and to find d. So for T1, I'm looking for something at the beginning, the first thing, or the first, in this case, the first height. So our T1, I'm going to look back at the question and notice that this is for children between the ages of 3 and 10, and that I know the child was 70 centimeters tall at age 3. So for my purposes, this begins at age 3, so my T1 is 70. Now that can be a little bit confusing. We'll talk about a way to sort out how T1 is 3 in a couple of minutes. Next, we need to have our D, and the D is the amount that something is changing each time. And so I'm going to look back up at my question and notice that there's an increase. And the word increase is going to clue me in to the fact that something is changing. And the increase is 5 centimeters per year. So I'm going to go with my common difference D is equal to 5. And then my general formula, I'm going to fill in T1 and D. So any term that I want, I'm going to start with my T1, which is 70. And then I'm going to use that in the formula, add on n minus 1 times the common difference of 5. Now let's use this general formula, which will apply for any question that has to do with this child's growth chart, to answer a specific question. And sure enough, part B asks us, how tall is the child expected to be at age 10? So I'm going to write out my formula. I now know that for my question, Tn is going to be 70 plus n minus 1 times 5. And if I'm trying to figure out how tall the kid is, I need to know how many years have passed. So what I'm really doing is I'm subbing in an n value. And here's where things get a little bit weird, because sometimes we might be tempted to say, well, I've got this age 10, maybe that's my n value. But we know that we didn't start at 1, we started at age 3. So we're going to take a little detour and just think for a second about what each age represents. We know that at the very start we had age 3, and then our next year would be age 4, age 5, age 6, etc. And we're going to go all the way up to 10 just to make sure we understand. My very first term was the 3 years old. Then I have my second term, etc. All the way up until I hit T8, which is age 10. So in this case, my n is equal to 8. And that always seems a little bit weird. If you want a formula to help you remember, you can think about taking your 10, subtract the starting point of 3, which gets you 7, and then add 1. So what we're doing is we're doing 10 minus 3, and then add 1 on at the end, and that will get us the 8 that we're looking for. So keeping that in mind, we now know our n value. We can plug it into the formula and figure out Tn. So we decided that n was equal to 8, and we're going to sub that into our formula. And one of the things about a formula is that everywhere there is an n, it's going to equal 8. So when we figured out that it took 8 times to hit age 10, what we're really asking is, what is T8? What is the 8th term in our list? And we also know that n equals 8 goes in our formula right here. And now we're ready to find T8 by taking 70 plus 8 minus 1 in brackets times 5. And we're going to use BEDMAS. We're going to start inside the brackets. So T8 will equal 70 plus 7 times 5. And we're going to do our multiplication. 70 plus 35. And then last, our addition, which gets us 70 plus 35 is 105. And we figured out that our 8th term is 105. It's a good idea to look back at your question and remind yourself that we were trying to figure out how tall is the child, and our question was given in centimeters. So we know that in T8, when the child is 10, he or she will be 105 centimeters tall. If you're asked to write out a sentence, it could look something like this. At age 10, the child is expected to be 105 centimeters.